right, so what we're doing today is we're going to go into verifying trig identities. This will cover assignments 19 and 20. 19 is all your multiple choice questions, and 20 will be your short answer. So as you can see, you have a box up here that has all the fundamental trig identities we have already covered. These are things you need to know, especially the part, sorry about that. I figured it out. Especially the part here where it says the Pythagorean identities right here. Those are something that you're going to need to know, and you will probably use these a whole lot. So please, if you don't have these committed to memory, have these handy so that when you are trying to verify these things, you know what you need to use and how you can convert. Now, the question is what the heck am I talking about? So, the fundamental trig identities are going to be used to establish other relationships among trigonometric functions. So to verify an identity, we're going to need to show that one side of the identity can be simplified and or manipulated so that it's identical to the other side. Each side of the equation is manipulated independently of the other side of the equation. So when you look at these, you want to be able to say, okay, can I turn this left side into the right side? What you are not allowed to do, you are not allowed to mix the two sides. So you cannot take something that's on the left-hand side and move it to the right-hand side, because now what you've done is you're no longer verifying an identity, you are solving an equation, and that's not what we're doing here. We are verifying. So we're trying to make the left equal the right or the right equal the left. Okay, so when you do these, you're going to start with the side containing the more complicated expression. If you wind up substituting one or more fundamental identities on the more complicated side, you'll often be able to rewrite it into a formal identity that's going to be identical to the other side. Now, there is no you have to do it this way type situation, okay? There's no one form or method or technique that's going to be able to use to be able to verify every single identity. You are going to have to think about these things, and you are going to have to apply all your knowledge from everything that we've done up to this point into these problems that we're going into. Some identities can be verified, especially or where did I come from? Verified by rewriting the more complicated sides so it might only contain sines and cosines. You might be able to rewrite it as a Pythagorean identity. However you do it, you're going to need to make your left equal the right or the right equal the left without moving things from one side to the other. Okay, so keep that in mind as we go forward. I'm going to make some more of these videos now from everything on are just going to be examples. I'm going to do a bunch of examples so you can see what's going to be doing, and I'm going to talk all the way through it so you know how to approach these, okay? So here we go. Let's go to the very first example. All right, so here's our first example. We are going to be changing the left side into the right side by using sines and cosines. So when you are given a problem that looks like this and you're trying to approach it, we're saying, okay, if I give you this, can I turn cosecant of x into secant x cotangent x? The answer is probably not, because I've got one thing on this side and I got two things over here, so that's just not going to work for me. But now, can I turn this secant x cotangent x into a cosecant of x? The answer is probably so. However, how do I do that? Well, if you look at the title, it says changing to sines and cosines to verify. So let's see if we can do that. So what you need to remember from your fundamental trig identities is that secant is the same thing as 1 over cosine of x. And then my cotangent is the same thing as cosine of x over sine of x. Okay? I'm multiplying secant and cotangent, so now I'm going to put these back together. I'm going to go 1 over cosine of x times cosine, oops, try that again, times cosine of x over sine of x. I can do some cross canceling here. And this leaves me, notice I'm not putting in equal signs, this leaves me with 1 over sine of x. Well, we know that from our fundamental trig identities, 1 over sine x is the same thing as cosecant of x. And this here gets us back to the actual problem that we're supposed to be getting to. So, with that being said, this is an easy one where you're just turning things into terms of sine and cosine. Now what I want you to do is I want you to try this one here. So we have cosecant of x, tan of x, and this is equal to secant of x. And what I want you to do is I want you to take a few moments, pause the video if you need to, take a few moments and try to solve this problem, turning the left side into nothing but terms of sines and cosines. And when you do it, you should wind up with secant x at the very end. Okay? I'm going to give you a few moments, so pause the video now. So if you notice, I've turned both of my cosecant into 1 over sine x and my tangent into sine x over cosine x. Put them back together. Do some cross cancellation here. And using my fundamental trig identities, I wind up with, which is what we started with. Okay? So that is the first type of a problem that you're going to wind up seeing. Not too bad, hopefully. So let's move on to example 2. All right, welcome back. We are now moving on to example 2. All right, so again, we're looking at this. We have all this stuff on the left-hand side and this one little bitty thing on the right-hand side. So obviously we are not going to touch the right-hand side. We are going to do exactly like we did in the last videos. We're going to turn the left-hand side into the smaller side. So we're going to tackle this sine x, tangent x first. So there's nothing that we can do with sine x, so we're going to leave that alone. However, the tangent of x we can rewrite as into sine x over cosine x. Okay? And then we're left with this cosine x over here. So that's the conversion piece. So now let's clean this up a little bit. We wind up with sine squared of x. That's 2 sines. That's going to be left over cosine of x plus cosine of x. Well, now I got a problem because that didn't help me any. So now I need to go back to fractions. If I've got a fraction and a whole number, what do I wind up doing to put them together? I turn the whole number into a fraction with the same denominator. It's the same thing as what we're going to do here. So I'm going to take this cosine of x and throw a 1 over it. And then I'm going to do upside down picnic table. Okay? So when I do that, I wind up with the following. Cosine times 1 will give me cosine x on the bottom, my plus sign on top. 1 times sine squared, it will just be sine squared x. Cosine times cosine winds up being cosine squared x. Now you're probably thinking, yeah, this doesn't help me out. But if you notice the numerator, what do you notice that is very specific about the numerator? Well, you should know, and there should be all these bells and whistles going off right here, that what is this? This is a Pythagorean identity. Boy, I can't spell today. Identity. Okay. We know that sine squared of x plus cosine squared of x equals 1. So instead of having sine squared plus cosine squared on top, what we're going to wind up having is I'm going to replace that sine squared plus cosine squared with a 1 over cosine, oops, not cosine squared, just cosine of x. Well, what is cosine of x? Cosine of x is secant of x. And that is exactly what we needed. Okay? So now, go into the next video. I'm going to go ahead and write the problem down for you. See if you can try this next problem all by yourself and then play the next video to see if you actually got this correct. Okay? The key is you need to remember your identities. I cannot stress this stuff enough. You have to remember these identities, otherwise you are going to struggle. So you need to make sure you understand. So here we go. We need to make sure that we put everything in terms of sine and cosine, which is what I did here. Okay, I'm going to clean up that top a little bit. So when I do that, I get my cosine squared x over sine x plus sine x. All right, I got a fraction, so we're going to put that and make that a fraction. And then again, upside down picnic table. And for those of you who don't remember, it looks like a picnic table. Okay, so I wind up with sine x on the bottom plus sine, because that's the sine. And then I have cosine squared x and sine squared x. There's my Pythagorean identity again. So I get 1 over sine x, and I wind up with cosecant of x, which is what I wanted. All right, welcome back. We're at example 3. So as we're looking here, it says using factoring to verify an identity. All right, so far we've done really easy problems, and you're thinking, okay, I can get this. This is not that bad. When is it going to start getting harder? Well, hopefully it won't. That's the whole goal, is hopefully this won't get any harder. So let's jump right into this problem. So if we're looking at this, cosine x minus cosine x sine squared x equals cosine cubed x. There is not much I can do with that over there. I have no idea or no way of turning it into anything. So I am not going to work with that side. What I'm going to do is I'm going to focus on this side here. And the biggest hint, especially in the example title, but the biggest hint that you should be seeing right now is I've got one thing in common with these two terms. So if I try to work this problem as it is, there's not much I can do, but I do know I've got something in common on both. I've got that cosine here and that cosine here. And looking at the title of this, we're going to be using factoring. So that means I'm going to come over here and I'm going to say, I'm going to pull out my cosine x. That leaves me with 1 minus sine squared x. And ooh, I'm getting closer. That's kind of fun. But I have no idea what to do with this 1 minus sine squared x. Well, actually you do. Because if I gave you, remember that arsenal I gave you at the beginning of all this that had all those fundamental identities and everything. What you need to be able to do is say, okay, how can I apply anything here into this? So if you go and look through that list, what is the only thing that has a 1 and a sine squared in it? Okay. If you think about it, the only thing that has it will be this. Cosine squared plus sine squared equals 1. There's a sine squared and there's a 1. Now, can I take this piece over here, manipulate it, and get this to be turned into something equals 1 minus sine squared? The answer is yes. So I'm going to take this sine squared over here and I'm going to move it to the other side. So I have cosine squared is equal to 1 minus sine squared. Ooh, that's kind of what it looks like over here, right? So let's rewrite and start manipulating a little bit more. So I can't do anything with this cosine x. That's just going to sit there. However, 1 minus sine squared x is going to wind up being cosine squared x, because I can substitute that in. So when I do that, I have cosine x and then cosine squared x. So when I multiply those together, I wind up with cosine cubed x. And that matches what I need. And this trig identity has now been verified. Alrighty then. So here we go. We are working on example 4. So we are given this problem. And if you notice, we no longer have a bunch of things on one side and then just one thing on the other. So we have two complex sides. So now the question is what side do I choose? Honestly, that's going to be up to you and your choice. So what I'm going to do is this is probably going to be in 2 videos. So we'll call this one 4A. So we are going to work this video on just the left-hand side only. Okay, so let's get started on that. So I'm only going to focus on this side, and I want to turn this side into that side. So as I'm looking at this, I'm going, okay, what do I do first? Because it's just a really ugly fraction. Well, if you remember, we have fraction rules that say if you've got a plus b all over c, this is going to be the same thing as a over c plus b over c. So we're going to take that same mentality and apply it to this problem here. So we wind up with 1 over cosine of theta plus sine of theta over cosine of theta. Now that we've broken this up, we can say, oh, okay, well, I have a property that says 1 over cosine of theta. Well, what is that? Well, that would be secant of theta. And then I have tangent of theta, and that says, oh, okay, well, tangent of theta is the same thing as sine theta over cosine of theta. So I can say sine theta over cosine of theta is tan theta. So there is our first one. And that actually went a lot quicker than what I thought, so I'm just going to continue going. And now we're going to do the same problem again, except this time we're going to do the other side. So we have 1 plus sine theta all over cosine theta. That equals secant theta plus tan theta. So now what we're going to do is we are going to focus on that side over here. So I'm looking at this. I want to turn this into a whole bunch of sines and cosines. So what I'm going to do is I'm going to say, okay, well, secant theta, because it's a fundamental identity, is the same thing as 1 over cosine of theta. And tangent of theta is going to be sine theta over cosine theta. Okay, I have two fractions. I have a common denominator. So if I put this together with that one common denominator, I wind up with 1 over sine theta all over cosine theta. And that is what that is. So when you get to these problems where you're getting more and more complex issues and complex sides to work with, sometimes it doesn't matter which side you work on because you can apply properties to both. So what you're going to want to do is kind of work together and try to get them to where it's going to be easier for you. Are you feeling more comfortable working with fractions? If so, you'll deal in this case on the left-hand side. Are you more comfortable with manipulating and turning things into the fundamental identities? If so, then you'll work on the right-hand side. So as you approach these problems, take everything that we've done up to this point and slowly just kind of figure out, okay, what is it that I need to do? Because you're the one who's in charge. And that's what you have to think about when you're going through this. You have to make the best decision. You have to make the best choice. And in order to do that, I need to know which one I'm going to be better at. Okay. Well, that is it for example 4. There will not be a 4B because I was able to do 4A and 4B together. So guess what? I will see you in example 5. Ta-ta for now. Heidi ho, everybody. We are now on to example 5. So now we are going to be looking at this identity and we're going to be trying to figure out how to make the left side equal the right side. Reason being is because I have 2 secant x on the left or the right hand side and there's not much I can do with. So I have to work on the other side. So what you have to do is you're going to have to say, okay, what can I do? We're going to be doing everybody's favorite thing in the whole wide world to do. You know what that is? That is going to be combining fractions. Remember how to do that, right? My famous upside down picnic table. Okay, where you have AD plus or minus BC all over BD. You're going to do that same thing over here on the left-hand side. So let's begin. Let's start having some math fun here. Okay, so we're going to multiply this straight across. So we have 1 plus sine x times cosine x. Keep that sign that's in the middle. Multiply up. Cosine times cosine is cosine squared x. 1 plus sine x times 1 plus sine x is 1 plus sine x squared. Okay. So now I'm going to ignore the bottom for right now because I don't want to touch it, because maybe when I clean up my numerator, I might be able to go through and cancel some stuff out. So right now, I'm not going to worry about the denominator at all. So as I'm looking at this, I'm kind of going, ooh, I have no idea what to do next. Well, think back to your algebra days. When you're doing algebra, we have this piece right here, and you see that little squared right there. So what does that mean that we need to do? You guessed it. We are going to need to expand that out. So if I've got 1 plus sine of x squared, like that, that does not mean you have 1 plus sine squared x. So for those of you who did that, stop it. Okay? We do not do that. So this means I've got 1 plus sine x times 1 plus sine x. We are going to expand this out, and I get 1 plus 2 sine x plus sine squared of x. Now, for those of you who are like, well, where did the 2 sine x come from? Well, you have one set right there, and you have the other one right there. Okay? So now, go back to blue. We're going to rewrite the numerator, but instead of 1 plus sine x squared, we're going to now put this whole entire thing in right there. So we have cosine squared of x plus 1 plus 2 sine x plus sine squared of x all over 1 plus sine x times cosine x. All right. And now we got a hot mess. So what you want to do, let's look at our numerator. As we're looking at our numerator, do you see an identity hiding in there somewhere? So hopefully you see that you have a cosine squared and a sine squared. Remember, cosine squared x plus sine squared x equals what? Equals 1. So now we're going to rewrite our numerator, but instead of the cosine squared plus sine squared, we're going to replace that, and we're going to replace it with a 1. So we have 1 plus 2 sine of x, because that's what's already there. And now I'm going to take these 2 that are right here, and I'm going to replace that with a plus 1. all over 1 plus sine x cosine, oops, forgot the C, x. Okay. Clean up our numerator a little bit more. I get 2 plus 2 sine x all over 1 plus sine x cosine x. Factor the top. 1 plus sine x all over 1 plus sine x cosine, forgot the C, x. Cancel. I wind up with 2 over cosine of x, which means I have 2 times 1 over cosine of x. Well, what is cosine of x? Cosine of x is secant, so I wind up with 2 secant of x. Okay? So, up to this point, they've been kind of easy. So now going forward, you're going to have to start thinking outside of the box and looking at things and going, okay, what exactly do I need to do? What properties do I need to do? What ideas, what, basic things from way back when do I need to apply to this? This was kind of a long one here, because we had a lot of, getting common denominator and then trying to find a hidden identity in here, like this one sitting right here. So don't just look at this and just throw your hands up and say, I'm done. Apply everything. You have to be able to apply everything. I can't stress that enough. Okay. Make sure if you have questions, you are emailing me and sending me reminds or whatever else. You've got my number or whatever. So keep up the good work. You guys are doing awesome. You rock. Why? Because you are awesome. All right. I guess I will see y'all in example 6. So TTFN. Ta-ta for now. All right. We are now back with example 6. So in example 6, you're given these two fractions that are set equal to each other. Now, reaction is that you want to go in there and go cross multiply and try to solve. Again, remember, you can't mix the left side and the right side. So in this case, since there's not much you can do with either one, what we're going to do is we're going to just pick a side. So I'm going to pick the left-hand side over here. That's where I'm going to start. And so what I'm going to do is I'm just going to go ahead and rewrite this. So sine of x over 1 plus cosine of x. Now, if you take a look at this, you will notice, I don't know what else to do. So kind of look over here on the right-hand side. This is a big indicator right here of what we should probably try to get to. And the only way of doing that is we're just going to go ahead and multiply top and bottom by that. And the reason we're doing it is because we are multiplying it by the conjugate of the denominator, if you think about this. So the conjugate goes on the bottom. And remember, what you do to the bottom, you must also do to the top. Okay? So now, when we go through this process, we wind up with, on top, we wind up with sine of x times 1 minus cosine of x all over this. Because it's a conjugate, it's a difference of 2 squares. So remember, if you have a minus b times a plus b, so the same thing with different signs, your answer is a squared minus b squared. So we wind up with 1 minus cosine squared x. Now, you're getting kind of closer, but again, what you have to remember is you have an identity sitting right here. Anytime you see a square pop up, first thing that should go through your mind is that's an identity. Because I know that sine squared of x is the same thing as 1 minus cosine squared of x. Okay? I know this because sine squared x plus cosine squared of x is equal to 1. And when I kick that cosine over, that's where that comes from. So with that being said, I'm going to rewrite this, but instead of 1 minus cosine squared x on the bottom, I'm going to rewrite my top as is. But on the bottom, instead of 1 minus cosine squared, I'm going to write sine squared of x. Okay? Now, this is the cool part, okay? So we have sine of x and 1 minus cosine of x on top. And now we have 2 sines of x's on the bottom. So if we take a look at that, that's what I'm doing. Which means if I come over here and I simplify this, I can do that. And then I wind up with 1 minus cosine of x all over sine of x. And that's what I needed. Okay? So remember, sometimes when you're going to do this, you're going to need to multiply the top and bottom by its conjugate to see if you can force the other side to happen. Remember, these are all puzzles. You have to look at the puzzle and figure out how are you going to solve this puzzle, because what works for one problem may not work for the other. Focusing on those fundamental identities is the biggest part of this whole entire thing. Okay? So that's it for example 6. We are going to move on to example 7. So I will talk to you there. TTFN. Ta-ta for now. All right, here we are at example 7. One more to go after this one. So you're going to take a look at this, and obviously we already know what side we're going to work with, so let's just go ahead and jump right into this. So when I'm looking at this, I'm only going to focus on the left side. So that's tan x minus sine of negative x all over 1 plus cosine x. So first thing that you need to do is you need to deal with this piece right here. And you need to know that sine of x is an odd function. So that means if I have sine of negative x, that's the same thing as negative sine x. So what I'm really looking at is tan of x plus sine x all over 1 plus cosine of x. All right, well, now what should I do? Well, if I go ahead and multiply top and bottom by the conjugate, it's just going to make it even uglier. It's not going to do much for us. So let's take a look here and let's go back to one of the things that we did earlier and convert everything that's not in terms of sine and cosine to something that deals with strictly sine and cosine. So tangent is the same thing as sine of x over cosine of x. And we're going to add that to sine of x all over 1 plus cosine of x. So I'm going to take this top one up here, and we're going to clean up this numerator and make this one really big fraction. And when I do that, so I notice I have a cosine of x and a 1 here. I can take the sine x on this side over here, and I can multiply top and bottom by cosine of x. So I wind up with sine x plus sine x cosine x all over cosine x all over 1 plus cosine x. Okay. Now we're going to go back and use something that we did earlier. So we're going to clean up this numerator still. And notice you have a sine of x and a sine of x. I'm going to go ahead and pull that out. And I wind up with a 1 plus cosine of x all over cosine of x. And this whole thing is all over 1 plus cosine x. All right, it still looks ugly, but if you actually take a look at this, you should actually be able to see how we're going to be able to reach our end. So we have a fraction over, technically a fraction because this part is over 1. So we're going to copy dot flip. So we have sine of x times 1 plus cosine of x all over cosine of x times, we're going to flip this bottom one. So that's 1 over 1 plus cosine of x. You are now in the home stretch because if you take a look here, what do you notice? You should notice that this 1 plus cosine x and that 1 plus cosine x cancel out. And that leaves you with sine x over cosine x, which is the same thing as tangent of x, which is exactly what we needed. So looking at this and going through, we had a really ugly problem up here in the beginning. There was just not much that we could work with. So we go back and we resort to sines and cosines, because if we go back to sines and cosines, we can take something that's difficult and maybe make it even more simpler by using just sines and cosines. We can break it down into something where we might be able to cancel stuff out, or we can move things around or combine things to get what we need. Okay, so that is it for this one. Now, when we go into example 8 is going to be a little bit different in example 8, and I will explain when we get there. Okay, so here's example 7. If you have any questions, make sure you're reaching out to me. Otherwise, I'll see you in example 8. TTFN. Ta-ta for now. All right, welcome back. We are on example 8. Yay! Why is that exciting? Because this is the last example for this section. All right, so let's jump right into this, because this might actually be a two-part video for this one. So example 8 is a prime example of you're not going to be able to make the left side equal the right side. Now, you don't know this yet. Why not? Because we haven't worked through the problem yet. So what we're going to have to do is you'll get to a point in this problem and you'll say, okay, I don't know what else to do. Well, you'll stop and then you'll start working the other side of the problem to see if you can get the other side of the problem to equal the left side of the problem. Okay? So we're going to start with the left side, and we're going to get to a point to where we can't go any further. So I'm going to start out with 1 over 1 plus cosine of theta plus 1 over 1 minus cosine of theta. Okay. Not much I can do with this except combine the two and make it one really big fraction to see what we wind up with. So when I do that, upside down picnic table, boom, 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 we wind up with on the bottom, we wind up with 1 minus cosine squared of theta. On the top, we have 1 minus cosine of theta plus 1 plus cosine of theta. Okay. Let's clean up this top here. So if you take a look, you will notice that we have a positive cosine and a negative cosine. So we're going to cross those off. Clean up the numerator some more, and you wind up with 2 over 1 minus cosine squared of theta. Okay. Still not looking like our right-hand side. So we can try to see what else we can do with this. I don't like that theta. Let's try that. There we go. So okay, well, what is 1 minus cosine squared theta? Well, 1 minus cosine squared theta is sine squared theta. So that's kind of where we're sitting at right now. Not much more I can do with this. So what we're going to do is we're going to come over here and we're going to look at the right-hand side. And that's going to be our 2 plus 2 cotangent squared of theta. So I can't do anything more with the left-hand side. So let's try to get the right-hand side. If maybe we can get that to simplify down into what the left-hand side was. So do the obvious one first. Pull out what they have in common is a 2. That leaves me with 1 plus cotangent squared of theta. Okay. Well, I got this 1 plus cotangent. Sorry about that. 1 plus cotangent of theta. Yeah, not really having anything to do with this one except maybe what? What is 1 plus cotangent of theta? You have to remember, if we have our sine squared plus our cosine squared and that equals 1, if we divide through, because we want to force cotangent, so we divide everything by sine squared. There's a sine squared there and a sine squared there. We wind up with what? we wind up with 1 plus cotangent squared is equal to, what is 1 over sine squared? That would be cosecant squared. So we know that this piece right here is the same thing as 2 times cosecant squared of theta. Got the theta. Okay. Well, but I got the sine theta over here on, oops, that's really big. Man, this thing's touchy today. I got the sine squared theta over here on the left-hand side. So I need to write my cosecant squared in terms of sine. So cosecant, remember that cosecant is the same thing as 1 over sine. So I wind up with 2 over sine squared of theta. And they both match. So I'm good to go on that. I got exactly what I wanted. Okay. So if you have any questions, make sure you're emailing me or whatever else. If not, I will talk to you soon. TTFN. Ta-ta for now.